let's get started here. My name is Mustafa. I work at Shopify, lead the engineering team that builds their main mobile app. Before we get into the topic, let's do a show of hands. Like, how many of you work on mobile apps right now? A few, sweet. So let's imagine a scenario where we're working on this alternate social media app, and things are going well. A couple of our friends are working on this together, and we're slowly getting users. And suddenly, one day, we wake up and find out that a lot of people have started using our app. Turns out some billionaire bought a social media network, and they're doing some questionable things. So a lot of people want out, and they are looking to move to a different platform, and they found ours, and suddenly we have this massive spike of users. So this is great for us because every startup, somebody who starts building a new product dreams of this day, and it's super exciting time. But what ends up happening essentially in cases like these is the initial excitement is quickly replaced by mortal panic, because we quickly get introduced to Murphy's Law, which states that anything that can go wrong will go wrong. Edward Murphy was an aerospace engineer, and he came up with this thing while working on aerospace technology, but this is especially true in terms of software. No matter how hard you try, no matter how diligent you are building systems, everything breaks when you get a lot of users, and you have to build and rebuild several times before you come up with something that's super reliable and works for you. So the thing about this is that building resilient systems on the back end is a fairly solved problem at this point. The practice in itself, like back-end engineering, has been around for a lot longer. So people have figured out how to build systems for scale and reliability. But mobile is much, much new in comparison. There's not a lot of guidance out there for how do you actually scale mobile products. So I thought I would talk about that. I've spent like the last 10 plus years working on mobile apps, some really popular ones, and made a lot of mistakes, learned a bunch of things along the way. So I thought I'll share that with you all today. So when you find yourself in a scenario that I described, like the first thing that happens is that, okay, like we have a lot more people using the product now, so let's add more engineers to the team. So before you know it, like you have like some more people working with you. Initially it was just you and your buddies. Now you have some new people coming in, joining you, and then it keeps growing and growing, and suddenly you have this like massive team, like hundreds of engineers going crazy. VCs are throwing money at you. It's crazy. It's a very hectic time. And what happens essentially, like you can't throw just more bodies at the problem and problems will just not go away. In fact, like a lot of times they just get worse before they get better. So let's talk about that first. Like, how do you scale your team? The main thing that you all can do is first we have to write everything down. When you're a small team, just handful of developers, everybody kind of know who's that person who knows how to answer a particular question. You can just like reach out to him, lean over your desk, talk to them. But once you have a larger team, that doesn't scale, because you keep pinging somebody, maybe they are not available, they are in a meeting somewhere, they are on vacation. What happens? People are just sitting around twiddling their thumbs because they don't know what to do. So the best thing you can do in this kind of stuff is at every level, like when you're a startup or you are a multi-billion-dollar company, write things down, make them easily available, make them searchable so that people know that where they need to go to find answers. The next thing you have to do is make onboarding super easy. The challenge that comes with scaling up quickly is that there are a few people who've been on the product for a while. They have all the context, they know exactly what needs to be done, and there are a bunch of new people coming in at the same time. Now, at that point, they are trying to build new features, fix issues, while also onboarding new people. So what ends up happening is all these new folks come in, they don't have all the answers, so they go and talk and ask questions to people who've been around before. And the thing is, they ended up like the older folks, the people who've been on the team for a long time, they get overwhelmed by like helping others, but also like doing the work that they're supposed to do. So if you make investments in making the onboarding process easier, just write everything down that people need to know, at least the basics before they get started. It makes everybody's life super easier. Same thing with training programs, like especially when you hire more junior folks. It's super helpful if you have a simple training program that covers everything a developer needs to know before they can start being productive in your code base. It seems like a expensive thing to do, but it pays off big time as you're scaling up quickly. The next thing is that when you have a bunch of people, you can't really have a flat single team. It doesn't really work that way. In a smaller startup, sure, it works, but as you have like tens or hundreds of developers, it doesn't scale. So you have to, at every stage, organize and reorganize your team to in a structure that makes sense. I've been at Shopify for almost 6 years now, and we've had to do reorgs almost 8 months because we're just like growing like crazy, and whatever structure we come up with doesn't scale beyond a certain point. The next thing that you have to do is you have to create teams with very clear mandates. It's very common for like startups to have like people who just work on whatever is the most important thing at that point of time. But as you have more engineers, it's important that every smaller group within that org has very clear set of responsibilities, and people are not stepping on each other's toes. That's how you can be productive as a team. So let's talk more about that. Like, how do you create different teams? So typically, there are 3 different types of teams that you'll have to create. So I'll talk about them next. The first one is what most companies call platform teams. These teams are usually comprised of the most experienced engineers, people who care a lot about architecture, clean code, things like that. And they will be responsible for, not emojis, but defining the architecture of the app, setting patterns for other teams to follow. It's very easy for code bases to go out of hand. Everybody comes in and does their own thing in their own silo, but then suddenly you have a code base that's just nobody knows what's going on. So when you have so many people working on a code base, it's very important to create patterns for people to follow. Like every feature in your app or any sort of software that you're trying to build needs to be built in a consistent way so that it's easy for people to contribute, and when something goes wrong, you have a way to go and figure out what's going on there. These teams also build reusable components. So for example, UI components you spend a lot of time building on. Larger teams, there's a team usually that is responsible for building all the custom UI components, and then all the other teams can just reuse them instead of reinventing the wheel on every screen. So let's say you have a custom button, just create it once, make it usable so that everybody else can just embed that in their screen versus having to build it over and over again. They are also responsible for building the foundational layers of the app. What does that mean? So every app has a set of like simple things that everybody needs. Like for example, how do you do networking? How do you consume an API? How do you do authentication? How do you do caching? You don't have to do it over and over again. Like, can you just build a layer that takes care of that for you? So if I'm building a feature, I don't care about how the networking and serialization and deserialization are happening. I just tell them, okay, hit this API, give me the response, and I'll be done with it. So stuff like that. Same goes with database, for instance. Like, how do you read write to the database? How do you cache the stuff? All that stuff can be taken care of if you architect your app well at a layer that the rest of the engineering teams don't have to worry about. The next set of teams that companies usually create are called feature teams. So these are the teams that actually are responsible for building features. Platform teams usually just build the platform itself. They don't usually build something that is like user facing. They build the scaffolding, but the feature teams come in and use that scaffolding to actually build the features that users will use. So they are people who are usually domain experts. So let's say you have, in our social media example, we want to provide a way for people to take pictures and upload them. So a feature team can be somebody like a team that is responsible for uploading images, dealing with all the different camera APIs, dealing with bitmaps, editing, cropping, stuff like that. And these are the teams that will basically build that feature, and they're domain experts in that, and they use the foundational layers to actually finish building that feature. They also contribute back to the foundation layer as needed, because the foundations team or the platform team cannot like always like imagine what every team is going to need. So as and when they come across something that doesn't exist, they can go back and contribute to the foundational layers as well. The third type of teams that companies create are what are called developer acceleration teams. This is something that is super, super valuable, and I don't see a lot of companies doing it right now, so I thought I should definitely mention this. The goal of this team is to just make every other developer in the organization more productive. They don't build anything that is user-facing. Their only job is essentially like, how can we make every other developer more productive in the team? They usually work on like internal tooling that will make people more productive. and they also own the CI and release infrastructure that your app needs. So let's see an example of the kind of things that a developer acceleration team builds. A very common scenario that everybody runs into. So you're working on a team, your colleague submits a pull request, and you want to test the changes before you give a thumbs up to merge. What do you need to do at that point? So you save your current changes, you switch to their branch, you pull the changes that they've made in the branch, you do a clean build. If everything goes well and Gradle plays nice, which is a big if, you compile the whole thing, you run it on an emulator or a device, 1 hour or 30 minutes, depending on the size of your code base, a lot of time has passed, and then you can actually test the changes and comment on the pull request. So the developer acceleration team at Shopify has built this tool that I'll show you a demo of. So I don't know how well you can see this thing, but so I'll tell you what is happening here. So essentially, it's a command line tool. We can give it a URL to the pull request that we want to test. What it does is it goes into our CI system and finds the APK file that was built in the CI for that particular branch. So the thing is, like, we've already done the work of building the APK in the server side. Why do we have to do it again on the client side? It's just wasteful. So we can just pull that APK locally and run it wherever we want. So what this tool, and it pulls the APK down, and then it asks you, what do you want to do with it? Do you want to run it on an emulator, or do you want it to run it on a real device? So in this example, we'll tell it to boot a new emulator. There's nothing running on our device right now. So we just select which emulator we want, and it will start a new emulator for us, wait for it to boot, and when it finishes booting, it'll automatically install the APK on the Android emulator and run it. So no more like changing branches and doing all that dance. Like, everything just like works seamlessly. You just like hit a command, press a couple of buttons, and you're done. Now this seems fairly simple, but the advantage of that really shows when you have like a bunch of developers on your team. Like, some teams have like over 100 developers now on mobile apps, and every time you have to waste time trying to like switch branches and dealing with build issues and Gradle configuration, clearing caches, invalidating and restoring. It all adds up, and at scale, all these like inefficiencies matter, because every time you save like 10 or 20 minutes, multiply that with like hundreds of engineers, it makes a big difference. Let's talk about testing next. So mobile apps are much harder to test than web products, because there are a bunch of different things that you have to pay attention to. So if you're building like hybrid or web apps, like, you can just test it on the mobile browser. You can use desktop browsers, and you can have emulators for that, so you can mostly get away with it. For day-to-day testing, simulators and emulators are usually your best bet, like fast feedback loop, and you can just test things very quickly. But when you want to validate your UI, testing on a real device is the best option. And also, when you want to test things like GPS or running things in the background, how do apps behave when there's a constraints on memory, when the device is about to run out of disk space and things like that, you have to test on a real device. There's no alternative for that. So based on like what I've seen so far, like, it really pays off if you invest heavily in automation testing. Yes, manual testing can be completely eliminated, but investing in a very solid automation testing framework pays huge dividends. Like at Shopify, we don't have a manual QA team at all. Like, most of the testing that we do is fully automated, and the way it is set up is that every time a developer pushes code, we run a big chunk of tests on the build so that we can catch issues early. And what kind of tests do we write? So most of the times, like, we write 3 types of tests: unit, integration, and screenshot tests. So unit tests are super fast to run, super easy to write, and you can use something like JUnit for running your unit tests, and they are intended to test the business logic of the app. Like, test really small functionality and run a simple test that verifies that every single time. This is super important, especially because somebody builds a feature they move on to a different part of the code base, or they leave the company and somebody else comes in and they want to change something, we have to make sure that they don't inadvertently break that business logic for us. The next type of test that we write is what we call integration tests. These are usually intended to verify the functionality of the app. So when you have like smaller chunks like of business logic, how do they come together and build comprise a feature? And integration tests are essentially designed for that. Most companies use Espresso, which we'll learn about more later today, for stuff like that. The third type of test that we write is what we call screenshot tests. So designers come up with a set of designs for the app, and they do their thing in Figma, and then they give us the design. And engineers usually miss small details, or it will change something that will mess up with the padding or margins and things like that, and you don't want those changes to go out without anybody noticing. So screenshot testing is a really cool way to prevent these things. So what you can do is, once you have an implementation of a screen that you're happy with, you record a snapshot of that screen. It's basically an image, essentially, like taking a screenshot on your computer. Now, what you can do then is, every time you make some changes to the UI components or that screen itself, you can take a new screenshot and then compare the two. And you can then easily catch if there's something has broken. A lot of times, like when you're using reusable components, you will change something in one file, but it will break something else in a completely different part of the code base. And when you have like hundreds of screens, it gets really, really hard to keep track of everything. So screenshot testing is this way to catch these things before they go into production. We built an open source library for this. It's called Testify, and it's available on GitHub. You can use that as well. The next thing is that when you're building mobile apps, fairly common knowledge, you have to run your tests on a wide range of devices, because you never know like what can break. Testing on the latest and greatest iPhone or Pixel phone is not enough, unfortunately. So you have to test on really different types of devices, so like low end, medium end, top end. And it's actually, like, especially when you're starting out, it's very difficult to go and buy all those devices and maintain them. It's super expensive and cost prohibitive. So the best option there is using something like Firebase Test Lab or BrowserStack. These are like virtual services where you can indirectly get access to these devices, and you can run your tests on it. Or you can even just, like, in the browser, you will have access to an iPhone or an Android device, and you can play with the app and see how it is working. Also super handy in testing like device specific issues. So let's say some low-end Samsung phone in some other part of the world, like our app is crashing constantly on, and we don't have that device with us. Just use something like BrowserStack, and you just go and access to that device, get the logs, see what's happening. So we built the app, we wrote a bunch of tests, we verified all the functionality. So let's talk about releasing next. When you have millions or tens of millions or billions of users, releases become a really big challenge. So the general rule of thumb around this is that you should ship small increments frequently. This is very different from the traditional software development model, where you work on something for months together and then ship it in big chunks. The problem with that is the more code you ship, the more the possibility of breaking something. So what you've seen work really well is, like, you ship in small increments frequently. At Shopify, we ship updates to all of our apps once a week. And we have a weekly cadence to do that, and it's working really well for us. Also, releasing a new update should be a shared responsibility. Typically, what ends up happening is the senior most person knows how to release, so they have all the access and keys and things like that, and they do it. But it's not scalable. It just becomes more and more difficult. And what if that person ends up going on vacation? They fall sick. They leave the company. It becomes a huge pain to manage. And then the best approach is just make it a shared responsibility. Everybody should know how to do it. Write it down, give people access, and then it becomes much easier. The third thing is that you have to really minimize the possibility of breaking something. Minimize is the key word here. You can't completely eliminate, it's just not realistic to prevent something from going wrong. The best you can do is minimize the possibility of that happening. And the way that we can do that, I'll talk about in a few minutes here. But let's talk about the release train model here. So typical software development process, you spend some time developing features, you create a release build, you do some testing on it, and once you're happy, you ship it. So the way to scale this is that you can basically do a lot of things in parallel. So once you create a release candidate, only the teams that are actually shipping code in that build can focus on testing their changes and making sure that they are working really well, while the rest of the team can continue doing feature development. When the release candidate is ready, you start releasing it to your user base, while the next build can be prepared for the subsequent release. And when you have hundreds and hundreds of engineers, like making all of them stop and test for a while and then ship it and then go back to development is extremely, extremely expensive. So you have to parallelize it. Think about it like multi-threading in a way, but for teams, you can actually like have a bunch of releases happening in parallel at different stages. So this is how we essentially do weekly releases. So every Wednesday, we create a release candidate. We do some testing on Wednesday and Thursday. Friday morning, we submit it to the app stores because iOS needs approvals and things like that. We go on, our weekend. Monday morning, usually like the app is approved, the update is approved, and then we start rolling it out on Monday onwards. And then Wednesday is the same thing, so it's over and over again. So let's talk more about like minimizing disruptions. So the main thing that we leverage is stage rollouts. So instead of making the update available to everybody, you do it gradually using stage rollouts in Apple and Google Play stores. So typically what is recommended is you first make a new update available to 1% of the users, see how it's happening, see if anything is going wrong, bump that up to 10% once you have confidence, then to 50, then to 100. But this is not like a hard and fast rule. You can basically do whatever makes sense for you. If there's any issue, like just stop the rollout right away so that you minimize the blast radius. The next thing is that you have to make it super easy to do a hotfix. So let's say you release something, 1% of the users got it, there's a new bug on some weird device that you haven't really seen before. Stop the rollout, fix it, do a new release. This helps a lot, especially when you have like millions or tens of millions of users, because this weird edge case that people will think, oh yeah, it's never going to happen, it happens, and it happens a lot. So a weird edge case that happens a small, very, very occasionally in a large enough user base is like happens thousands or tens of thousands of times, and you have to care about that. The next thing you can do is use feature flags. These are really cool. So these are essentially like a Boolean that you set on the server side, and then you can use them in a bunch of different ways. So you can use them to turn features on and off in production. So the way it essentially works is whenever you are launching a new feature, you can put it behind a feature flag. So when the app runs, it checks, okay, is this feature available to this user? It's a Boolean value that comes down from the server, and then if it's true, it makes the feature available. If it's false, it just hides it. Now, the cool thing about this is that if you want to make any changes and you can show or hide a feature, you don't need to do an app update. That is really, really powerful, because even if you do weekly updates, like we have users who just don't update for 6 months at a time. And you can't really just like wait until everybody's running the latest version of the app. So imagine we release a new feature and something goes wrong. We can very quickly turn it off and just like work on fixing the issue while the app is stable for our users. You can also use that for running beta programs. So let's say you're building a new feature that you want to test with a small subset of your user base before you actually make it available to everybody. You can use feature flags for that as well. So let's say you identified like, 50 users that you are working closely with to test a feature. You can make the new feature available only to them. And this is not limited only to features, actually. Like we use this for even refactors and large refactors. So let's say we are rewriting a part of the app, we can just put it behind a feature flag and then roll it out gradually. even so when you have like staged rollouts in the App Store, but you can have staged rollouts in feature flag as well. So as you're making a new feature available, you can add another layer of like staged rollouts on top of it. So like, okay, let's make this feature available only to 1% of our users and see what happens. So it gives you a lot of flexibility. A few tools that you can use for something like this are Firebase Remote Config, Optimizely, and Launch Darkly. And if you're a big enough company, you can build your own that really suits your specific requirements. So doing weekly releases is a lot of work. It's not easy, so automating it is really, really useful. It's a lot of manual work that can be automated, and you'll save a lot of time and just make it, you eliminate the possibility of people making mistakes as well. So the first thing you should do is train everybody how to do a release and then document how to do it, but also try and automate that as much as possible. Fastlane and App Center Distribute are fairly good ways of automating a lot of this. I'll show you how we do it. So we have this tool at Shopify called Ship It Mobile. What it essentially does is it facilitates app releases, and you don't have to do a lot of manual things yourself to be able to ship a new update. So you have to just go into that tool, go into the app that you want to release and create a new release there. And when you hit that release button, what it does is it takes the latest commit off the main branch and then creates a new release branch and builds it and runs a whole bunch of tests on it. And then you can see the status of the builds here. The other thing it does, which I find it really useful, is that it sends a Slack notification in your team channel saying that, hey, a new release has started. So you don't have to go and babysit the build. And once a build is ready, you'll get a notification. So you're not sitting there just like refreshing your web page or whatever, right? So let's say a release candidate is ready. People do a lot of like manual testing on it, verify functionalities and things like that. Now we enable a bunch of buttons here. So if you want to upload the new build to the iOS App Store or the Google Play Store, you don't have to go fiddle around with their consoles. You just hit a button and the binary gets uploaded there. So once the binary gets uploaded, you get a notification. In case of Apple and iOS, you have to wait until they approve the build. And what you end up doing usually is like keep checking your email or the App Store Connect dashboard and things like that. Who has time for all that? So we automated that as well. So whenever the build gets approved, we get a notification in Slack, because everybody is in Slack, and you can just go in and start the rollout there after that. So the last thing I want to talk about is reliability. It becomes more and more important as your user base grows. And there are a bunch of different things that you'll have to do differently at scale when it comes to reliability. The main thing is you have to set up automated monitoring and alerts. There's a lot of different things that can go wrong, and you can't wait until people come and tell you that, hey, your app is crashing. You have to know that something is going wrong before it gets out of hand. So setting up automated monitoring and alerts is super, super important. You have to track crashes and errors. Most people do this by using things like Bugsnag and things like that. But the other thing, when you are at scale, is what you have to do is set up an on-call process. What that essentially means is that you have engineers available at all times to jump in and investigate issues as they occur. This is super, super important when you have a large user base. The next thing is that when you have yeah, go ahead.
Are the on-call engineers were the ones who release the feature? So they are rotating.
So the question is like, are these engineers who are on call the same engineers who built a feature? But that's a very good question. I'll have a full section on that, so I'll just cover that in a bit. The next thing is like you will have outages. You can't really just like avoid it at all. So you have to change your mentality from like how do I prevent outages completely to how do I minimize the possibility of an outage and also reduce the amount of time an outage is occurring as much as possible. That should be the way that you'll have to think about this. There are a bunch of different tools out there that were built for the backend, but you can use them for mobile as well. So like Datadog for crash reporting or monitoring, Bugsnag for crash reporting on mobile apps, PagerDuty to manage your on-call, and AppsFigures to track the App Store reviews. This is something that a lot of companies are trying to do now. So a lot of times bugs get reported as a form of your App Store review. Somebody leaves you a 1-star rating and yells at you for breaking something. That is a really cool way, easy way to know what's going on in your app. But the problem is Google and Apple don't make it very easy for you to review these things. You have to go into the console and go see what people are writing reviews for your app. But using something like App Figures, what it essentially does is it monitors your App Store pages, and every day it sends you Slack notification with all the new reviews that have come, and also any review that was updated, so that you have all of that in one place and you can go reply to reviews and see what's going on and things like that. Right, so let's talk about handling outages now. We know that they will happen, so what do we do when they do? The typical rule of thumb here is that you should have at least 2 on-call devs at all times. These don't necessarily need to be the same people who build a feature, but it's a rotating responsibility essentially. So every engineer on the team is in a PagerDuty schedule, and it's a round-robin thing. So every week, 2 people are on call at a time for a week. Now, why 2 people? So the one person is usually called the primary and the one is secondary. It's usually meant for as a backup. So let's say the main person, the primary on-call dev, maybe they have an internet issue, or they have an emergency to deal with, or there are multiple issues that are happening. It's usually nice to have another person to just be there to help them out. Now, what do? So the main responsibility for them is to monitor health of the app and resolve any outages as they occur. They are not responsible for fixing every single bug or a crash that occurs, but they are responsible for coordinating the fixing of that issue. So they can pull in any people that they need to actually fix an issue. So they are the first line of defense. So when something goes wrong, they monitor it, they try to reproduce it, see what's going on, pull in experts who have worked in that area and work with them to ship an update, or stop the rollout, release a hotfix, things like that. This is really, really important when you are at scale, because usually what ends up happening in smaller teams is that you have a team Slack channel or whatever, and something goes wrong, everybody jumps and tries to fix it and moves on. But when you have hundreds of engineers, that is a lot of wasted time if everybody's jumping on it. It's like watching little kids play soccer in a way, everybody runs to the ball. No, it's not very useful. So what you need to do is have your rest of the team, give them the ability to focus on the day-to-day work, while you have important people who are on call deal with issues, and they can pull in people as needed. So let's talk about how we at Shopify do this. This is an example of a real thing that happened a while back. We noticed that API requests to a certain endpoint kept failing all of a sudden. So if you see here, so this is a screenshot from our Slack, 97% of the calls that are making to an endpoint started failing randomly. And you could have a dashboard to monitor these things, but then we automated all that. So whenever the number of error goes over a certain threshold, we get notified automatically. So when this happened, the person who was on call was like, this should work, why is it not working? And what they did is, so we have a Slack bot called Spy. We've written about this, you can find it online. So this is a bot that we use to manage outages. So what you can do is essentially start a local incident, which is basically means, okay, something is going wrong and we need to jump on this. This is an urgent matter, and it's sort of like a state of emergency for the team. And what you can do essentially is just tag the bot saying that, hey, start an incident, this is something is going wrong. The thing about this is once you do that, it basically starts and it creates an incident, and behind the scenes it will notify a bunch of different people. So support team gets notified that, hey, the developers are aware of something that's going wrong in production. Leadership gets pinged hey, this is something that's going wrong. If you need to bring in partnerships, legal, security, whole bunch of teams can get involved if need be. So everybody gets alerted that, hey, something is going wrong and may need your attention. Now, all the engineers jump in and try to figure out what's going on. The on-call devs pull in people as needed. One thing that happens usually when you are dealing with incidents is that a lot of information is shared about the incident, and it's very important to make a note of that, because otherwise it's lost. Like Slack history, for instance, is just for a few days, and it will get deleted automatically, and then you don't know, you'll have to rely on your memory to know what happened at that point and who did what, and things like that. So one of the things that we did with this Slack bot is we added the ability to take notes, but in a very interesting way. So let's say you're in the Slack channel, there's a whole lot of things happening, people are trying out different things, we're getting more data, and you want to take notes. So what you can essentially do is anything that you want to take a note of, you add a memo emoji to that message. It's super hard to see here, but it's basically like a paper with pencil. And what the bot does is essentially takes a note of whatever that message was and who said it, and it will acknowledge that by adding a checkmark emoji. So as you're dealing with issues, the last thing you want to do is like copy paste things or take screenshots of what people wrote and things like that. So you can just like add an emoji and you're done with it, and it's all recorded somewhere else. So let's say in this particular case, what happened was some backend devs made a change and did not test it thoroughly, so it broke something in production for mobile users. So let's say we go and reverted that commit. The Datadog thing that the tracker basically noticed that, saw that all the requests are getting successful now, so things are not broken anymore. So people on the team went ahead and tested it manually as well, just like one more time to make sure that everything is working correctly. And then once we were happy that everything is back to normal, we stopped the incident. And at that point, the bot will acknowledge that, like, yes, the incident has been closed. So what it essentially does is it takes all the data about the actual incident and stores it in a different system that we have, and we use that to monitor our overall uptime. And all the notes that we took, everything is there, who were involved, things like that, and it has a lot of like tooling to remind you to make sure that you do a retrospective and things like that. So once we fix the issue, the next important thing is that you have to do a postmortem and try to figure out what went wrong. The way that we typically do is we use this framework called 5 whys. So you basically ask why something happened 5 times. So 5 or more times. So let's say in this particular case, request to an API started failing. Why did that happen? A backend engineer changed something on the server side but did not test their changes on the mobile app. Why did they not test it on mobile app? They didn't have a device. So why didn't they have a device? So like they didn't know how to order a mobile device for testing. Why did not know how to do it? Like it was not documented. Like, okay, so let's take action items from this. Okay, let's figure out what do you need to do. So let's say document how we order test devices, add a step when you're shipping code that, okay, you need to go and test on mobile devices as well, and try and like come up with a bunch of action items to prevent the same thing from happening in the future. As you're doing this, the most important thing is that you need to focus on what went wrong and not who did something. It has to be a zero blame thing. You have to assume that people are trying to do the right thing, but sometimes things will go wrong. It's part of what you're trying to do. So as you're doing this, like it should be super clear that, okay, let's talk about what exactly went wrong and not about whose mistake it was. And you create a good team culture that way. Otherwise, people are just like going to find other people to blame or just make excuses, and which is not productive, because stuff is going to break. We just need to make sure that it doesn't break for the same reason more than once, right? So that's why you have to come up with a process that works really well and create a culture that supports people from like, you shouldn't be scared of doing something. And if something goes wrong, it's okay. We learn from it and move on. And like I said, once you do this retrospective, you come up with action items, do a bunch of changes that you need to, and then just make sure that this doesn't happen again. So that was a fairly high-level overview of the kind of things that you have to do when you're dealing with mobile apps at scale. Have you take any questions at this point? Yeah.
Hi, thank you for you talked about the onboarding process. So how long do you expect like the new hire to be proficient enough or to be like knowledgeable enough with the system to be like on call, on the rotation, and kind of
Yeah, so the question is like, how long do you think it's going to take for a new engineer to be proficient enough to be able to go on call? Typically, we put people on call once they've been at the company for over 2 months. That's more than enough time to know the basics. And the thing is, like, they don't need to know how to solve the problem. They just need to know how to coordinate a fix. So it's also a good way for them to onboard as well, because they get exposed to a lot of things that they would normally not do. So we usually wait for 2 months and then add them to the on-call schedule. Yeah.
Thank you for your presentation. I would like to ask, like, in terms of a new developer, suppose joining to Shopify, like, in respect to the work culture that you explained, like, how flexible are big techs, like, to making mistakes? Because suppose a new graduate or some new developer joining, like, is it a one-time thing, or like how flexible are they?
So the question is like, how flexible are companies to like people making mistakes?
Yeah.
In my experience, it's fairly flexible. The culture in like modern companies is usually like things are going to break, and almost breaking production is a rite of passage. Everybody does it at some point or the other. The focus is like, how do we make it as less possible, and when it actually happens, like how do we recover completely from it? Like, for example, I broke production a few times at Shopify, and what we essentially do now is we try. It's the same thing on the back end as well. Like, you ship your changes to a very small subset of users, see if anything is going wrong, and then you just revert changes. So let's say when you're working on back end, this is super cool. I'm super jealous of our back end devs. So on the back end side, let's say you shipped some changes that are breaking things in production. You can just do one Slack message and it will automatically revert those changes. You don't have to go into a system, you don't have to go into Git, do other things. It's just like one Slack message, and that's it. So mobile unfortunately doesn't have that yet, but let's see if we can build something like that. Yeah.
Just out of curiosity, so how do you compensate on-call duty on the out of working hours?
Say that again, sorry?
How do you compensate for the on-call out of working hours?
Yeah, so the question is like, how do companies compensate for on-call work done outside of office hours? So every company has their own way of doing it. Some companies pay overtime. Some companies give time off, extra time off to do it. So it all depends on like what the process of each company is.
I have a question. So whenever you have the outages, do you generally give the previous version build to them and then resolve the outage and then give the new version, or you just gonna keep the customers on board?
Yeah, the question is like, when an outage happened, do you just revert to the last good version, or do you like do a forward fix, which is like you implement a fix and then publish a new build? The answer is like, it depends on what exactly is happening. If it's a minor issue, and we have very good confidence in the fix, we just do a forward fix and just like ship a fix instead. If there is like a big issue that we can't really diagnose, like, and don't know what's going on, to stop the bleeding, we'll just go back to the previous version, bump up the version code, and just ship that, and then while we figure out what's going on.
So I have a question about the costing quality and the development part. For example, last week I was working on a project. I was responsible for testing, and my coworkers continued to do the development. But for us, like, what we realized, it took us so much time to realize like, why are the tests failing, because some people changed stuff on the back end, and it took us a lot of time. So is it something that's expected, or did we do something wrong? Like,
Yeah, so the question is like, when you're working on something and the feature is broken because, let's say, some backend team changed something and it took you a while to figure out like what's going on, like, is that normal? It is common, it is fairly common, and especially common when you have, if you're using APIs that are built by a different company, for instance. Within the same company, there's a lot of ways you can prevent that. So you can have the backend team, for instance, write tests that make sure that whatever the clients are expecting, the test will always verify that, so that they don't mistakenly change something. On the client side, you can write integration tests as well. So you can, without the UI, you can hit the API, get the response, make sure that is matching exactly what is expected by the app. And then if something changes, it breaks the test so that your build will fail and you'll know what's going on the moment it happens. So bunch of different ways you can do that. It all depends on like how the company is structured and what kind of APIs you are consuming.
I mean, like specifically, let's say I wrote a test about a method, and someone on the backend changed the method while I was writing the test. So like it took some time for us to realize, like for the backend person to be like, okay, oh, I changed this method, that's why the test is failing. And like, is this an expected iterative process?
No, it's not expected. There are a bunch of different ways you can deal with that, right? Like one thing is you need to agree on an API signature with the backend team. Like, okay, I will send you this, you will return me this, and then everybody adheres to that. One way teams work around this is having mobile and backend devs work it together in a single team, so that it's not a different team. You're all like working on a feature together. So cross-functional teams. We have Android, iOS, backend devs, web devs, all working together. So you can really make communication easier that way. So a couple of ways you can solve it. Yeah.
For the management of release flags, when you do small level rollouts, how many iterations of your infrastructure do you manage? Because the problem is, if there are major breaking changes in the API between two versions, how many copies of the infrastructure are you making at the same time? Because that's usually the big issue. If you're running a big version 1.999 and a version 2, how many copies of the infrastructure are you making?
Yeah, that's a very good question. So the question is, when you have like big breaking changes in the API, like how many versions of those APIs do you actively support? Because people don't update as quickly as you want. So the way that we typically do it is we try to support only one major feature version of an API at any given point of time. We have a kill switch in the app that we can actually flip if we want to force every user to update to a new version. So we don't use it very often, but in special cases like this, like let's say you haven't really updated your app in 6 months, and now we need to get rid of this other version of the API that is just not scaling. We can flip that switch. When you open the app, you will be shown a message saying you can't use this app anymore until you update to the latest version, and like a button that takes you to the app store to update it. So we do it we try to not be disruptive, but we have that as a backup if we really need to do it. It's super helpful in security issues as well. So if we find any big security vulnerability, everybody needs to update.
Are you running RPCs or are you running REST for your interface in the backend?
So the question is, do we use RPCs or REST? We use GraphQL, and like all of our APIs are GraphQL based. Any other questions? Yeah.
I have a question about release management. We have too many release strategy. Like one of them is what you said, that based on a specific date, for example, every week or every 2 weeks, every sprint. Or we have another strategy, like we have to have this amount of features to come to the main branch or something, and then we can release which one do you prefer and which one is better for each requirement of the company? And my other question is that, okay, whenever we release into the production, we face an issue, and what is our approach to hotfix those issues, and when we should make another release to fix them?
Sure, a couple of questions there. First one is, should we wait until like we have a bunch of features to ship versus like shipping on a schedule? My personal preference is shipping on a schedule because, like I said, more code you ship, the more chances of breaking something. But in a larger team, what you can do is you can put unfinished features behind a feature flag. So you are shipping the new bits, but they are not usable by the user. So you can keep merging to main as you normally work, but you can only make the new feature available when you are fully ready. So you can ship things incrementally without actually like breaking things in production. And anytime you ship new changes, it's like a smaller delta over what was already shipped. So you can actually catch issues much easier that way. The second question was, how do you decide when to do a hotfix versus just like doing it in the next release? The way that we do it is that we have different severity levels for an issue. Sev 1 is all hands on deck, things are on fire, everybody needs to jump and fix this as quickly as possible. Step 4 is ship it when you can, or fix it when you can. So when an issue comes in, we categorize it into like 4 different categories, and if it's severity 1, it needs to be hot fixed immediately. And then we use that as a framework to decide whether to hot fix or not. Yeah.
My understanding is that Shopify works globally and targets like a ton of different platforms. So how do you, like, when you scale like this, how do you prevent like your different platforms from being like the feature drifts, like different features? Like your Android is going to ship something that's not available yet on iOS or on your web platform maybe. So how do you keep everything in sync across like your multiple teams and projects?
Yeah, the question is like, how do you make sure that you keep Android and iOS and different platforms the same page and not like have differences between them? The current way of doing that is using React Native. So you just build a feature once and make it available on both platforms. But that's not the only way. Like some things are not technical; they are like more team related, and you can do like team related things. While like having a cross-functional team makes a big difference. So instead of having an Android team and a iOS team, you can just have one feature team, and they are responsible for building the backend, Android and iOS version of that together and shipping it together versus every team doing their own thing in silo. So that usually helps as well. Yeah.
Going back to the first question that you had, like you suppose that new hire should be ready to go on call after 2 months, right? So let's say the new hire is going on call as a second week in their third month, then how are like they wouldn't know because the code base is really huge. They would hardly know where to go and fix the code if there's some issue. Then like they would always go to the primary. So but primary is already like in their zone as well because they have to solve much tickets than the secondary. Then how can the secondary be not overridden on the primary?
Yeah, the question is like how do like new on-call devs not be a burden on like other team members? Typically, like we do a bunch of different things. Number one is we have training programs for on-call as well. So we call them on-call mentorship. So you can go shadow an experienced engineer as they are on call and just learn from them behind the scenes and help out if needed. The other thing what happens essentially is that it's very, very rare to have more than one fire to deal with at any given point of time. Extremely, extremely rare from what we've seen. And even if, let's say, that happens, like there are other engineers usually around to jump in and help out. So it's not that only like those 2 people are like responsible and available. Like the rest of the team is like backup by default, and you can just pull them in as needed. Yeah.
Since you guys have both Android and iOS app, do you guys use KMM?
Yeah, the question is like, since we have both Android and iOS apps, do we use KMM? The answer is yes, but not for all apps. So we have 5 mobile apps that we work on. One of them uses Kotlin multi-platform quite a bit because it touches a lot of native APIs. That's our point of sale app, and a lot of hardware-related features. So it's an app that you can use to connect to an external card reader or Bluetooth or USB and take payments. And since it requires a lot of like native APIs, we don't use React Native for it because performance is really, really important, and then we use KMM as a native stack for that. Yeah.
What do you think about shifting left by making testing parallel to the development cycle? Have you ever worked like that, or do you think about that?
Yeah, the question is like, what do I think about making testing as part of the development cycle? It is that way essentially right now. Every time an engineer builds a new feature, they are supposed to not just build the feature, but also write tests that test that feature, all automated tests. We don't have, like I said, we don't have a QA team, so essentially engineers have to do all that. And the automation tests are also written by the engineers who build that feature. We don't have a separate test automation team that's only responsible for writing tests and things like that, no. You build it, you make sure that it runs well. If because it's broken, people will come and ask you to fix it. So the incentives are aligned there. Yeah.
Another quick question. merging process? How many approvals you need? How many people review a PR?
Yeah, so typically what we essentially do is any pull request should have at least 2 approvals before it's merged. It's not a hard requirement in most repositories. Let's say there's an emergency, it's outside of office hours, close to midnight, something is going wrong, you can always like merge without a second approval. But the idea is that you have to go back and make sure that whatever changes you ship gets reviewed by the right people. Another cool thing that we do essentially is when you have a large code base, build times become pretty large, and you can like build, you can change something, get the approvals, but then you're just sitting around waiting for the build to finish before you can merge it. So we added automation that you can add a comment on your GitHub pull request saying /ship it. And what it essentially does is as soon as the build is successful, it will automatically merge it. You don't have to babysit it. You don't have to sit around and wait until it's merged. A lot of times what ends up happening otherwise is you get approvals, you're waiting for the build to complete, and then a bunch of other changes have gone in, and then suddenly, like before you merge, there are a bunch of merge conflicts. And then you have to go resolve those merge conflicts, get approval again, because there's a good chance something can break, and then you go into that same loop over and over again. So what we did is like, as soon as the build is green, just merge it before there are any merge conflicts, because when you have so many people that are working in the code base, you will get merge conflicts otherwise. Any other questions? Sweet. Thanks, everyone.